session, it will be moderated by Mr. David Lin, manager of Far Eastone. Okay. And we have two speakers for this panel again. And I'll let Mr. Lin to introduce your speakers. Okay, thank you. I'll hand the floor to Mr. David Lin, please.
Okay, thank you. And welcome to join this session. I'm David Lin, and from Eastone telecom operator. And my responsibility is the IP network infrastructure, the planning, and the capacity, the planning. And today, we have the two speakers. They will share their experience of the operational technology, and they will give you some information. And okay, and this one first, Mr. Hui-Kai Su, Dr. Hui-Kai Su. He is the professor of the National Formosa University, and he farms the many domain knowledge, including the communication network and the IoT and multimedia and embedded the system added. And so he will share some information about the hot topic of the IETF 119. And let's welcome Dr. Su. Okay.
Okay, thank you. Thanks, David, in the introduction. Okay, today I will talk about the introduction to IETF hot topics. Okay, I'm from National Formosa University. Okay, this is my outline. I will introduce the IETF 119 first, and then talk about the IETF hot topics. Finally, I will give some conclusions. Okay, the IETF 119 proceedings were hosted from 16 to 22 March 2024. The location is in Brisbane, okay, and the figure is the remote login the conference, okay. So I will join the conference in this duration. Okay, this is the participants that from the world. Okay, so the registration users is about 1,429. Okay, some user is remote attend the conference, and some users is on-site the conference. The on-site users is about 687 users. And the right-hand side, the figure will show about the distribution of the users come from different countries. Okay. The left side, the figure shows about the on-site users, and right-hand side is show the remote users. Okay, so many users come from different countries. Okay, this is the registration users in different from the IETF 113 to IETF 119. Okay, we can observe the user increase every conference. Okay, and the hot topic I collect from the RFC lightning talks in IETF 119. Okay, the proceeding is hosted in the March 17. Okay, so the video you can watch from the YouTube. Okay, so this is public. There are 12 hot topics discussed in this section. Okay, the first is talk about the large language model for networking. And second one is human-centered ICT. And third one is DDoS trend and defense issues. Okay, so we can observe many topics is cover application, general topic, operation and management, and security issues. Okay, so I select 4 topics to share you. Okay, so the first one is the large language model for networking. And second one is DDoS trend and defense issues. Third one is personal digital agent protocols. Okay, the last one is adapt video traffic shaping problems. Okay, the first topic is the large language model for networking. Okay, if you research on the ChatGPT or some related topics, I think you will interested in the topic. Okay, so the background is about the emergence of ChatGPT has marked the beginning of a rapid development era for the large language model and the aggressive AI. Okay, so the language model includes many models. Okay, so we can say that the large language model is combined different models. Okay, so this topic is about the LLM applications. Okay, this figure shows the users to access the model and then obtain the results. Okay, so the top left is the network task, is the user agent. Okay, so you can ask the model, and the process flow will give the prompt. Okay, the right-hand side is about the foundation large language models. Okay, so the large language model combines different models, just like the ChatGPT or the Gemini and so on. Okay, so finally, the model will query and calculate, give the results to the users. Okay, so the users may be validate the results and feedback to the prompt engineering. Okay, finally, the action will obtained by the users. Okay, so this is the large language model in the loop architecture. Okay, so the LLM in the loop architecture for the network will face some challenges. Okay, so the developing method to represent heterogeneous network information is a method compressed to the LLM. Okay, classifying the LLM roles is specifically the task to present the heterogeneous ensure desired outcomes. Okay, so the user may be faced the correctness and safety problem. Okay, so this topic will talk about these issues. If you are interested in this topic, you can focus on the RFC Lightning talks in 1991, the third topics. Okay, second topic is about the personal digital agent protocol. Okay, this protocol is related to the large language models. Okay, because in this model, some private data may be exposed to the external large language model. Okay, so this protocol can enhance the security problem. security and privacy problem. Okay, so the first stage is about the authentication in the step 1 and step 2. Okay, so the user agent will, after the authentication, the user agent will access the large language model with your privacy data. Okay, so your privacy data will translate to the LLM. So the LLM model is in the external site. So your privacy data may be exposed in the public area. Okay, so the professional agent protocol is enhance the issue in the architecture. Okay, so this is the broad chart to explain the process. Okay, so the personal digital agent protocol principles, the goal is to protect the resource and standardize the GNAP authentication token and standardize the policy description language, choosing policy description language, and so on. Okay, so if you are interested in the PDAP, okay, you can focus on the 11 topics in the hot RFC library. Third one is about the security area. Okay, the DDoS trend and defense issue. Okay, this issue is big problem increased in every years. Okay, so the enterprise may be to face the high defense costs. Okay, because the DDoS attack randomly and long-term persistent and operation of large-scale DDoS defense resource come at every high cost. Okay, some attack is more intelligent. Okay, so the fast flooding and new means about the new protocols or new attack. Okay, so the attack is hard to detect. For ISP, sampling-based attack detection usually takes more than 1 minute. New types of attacks are emerging, and intelligent attacks occur more frequently. Okay, so this is a big issue for enterprise. This is a use case about the attack. In the left figure, we can observe the fast flooding attack from the network operator to the enterprise. For operator, detect attack in minutes. Okay, have enough resources. But for the enterprise, detect attack in seconds, limited resource to migrate the traffic. Okay, so in this case, the enterprise require a new protocol to negotiate with the operator. Okay, just like the flow chart in the below. First one, the enterprise can request the migration to the operator, and the operator can acknowledge the attack and cooperate the migration with the enterprise. Okay, so this topic is focus some key elements. The first one is called operating migration, and second one is DDoS open train signaling. Okay, so if you are interested in the security topics, I think you can focus on this session, this page session. The final one is the adaptive video traffic shaping. Okay, the problem is that the shaping may occur the traffic, some ping pong effect. Okay, so the traffic shaping function is not good for the video streaming. Okay, this is work. This can work, but you have to face some problem, just like the underutilization bandwidth, okay, or the ping pong effect, and so on. Okay, so this area we will discuss a new adaptive measure for the standards. Okay, so if you are interested in the adaptive video streaming, I think you can focus on this session. Okay, so I give the conclusion about the hot topics. Okay, I observed in my observation in the IETF 119. Application is about the large language model, and some security issues are discussed, just like the key exchange, okay, and authentication method, and so on. Some international transport are also discussed in the session, just like the adaptive traffic and video traffic. So standalone video ID, and some operations and management, just like the surface management, DDoS issues, and so on. Okay, so that's all about the hot topics in IETF 119. And the IETF 112 will host on 20 July to 26 July in this year. Okay, welcome, everybody can join this proceeding. Okay, that's all is my talk. Thank you for your attention. Thank you.
Okay, thank you, Dr. Su, and thank you for your sharing about the hot topic of the IETF, and it's helpful for us to understand what is going on in the IETF standard is so on. Okay. 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 Next one, the speaker is the Yeung. He's from the Akamai Technology. He will be sharing the traffic flow optimization issue. And okay, let's welcome the James.
Yep. Hello, everyone. My name is James. I'm one of the network architects from Akamai. So today I'm going to talk about optimizing the traffic flow with Akamai. So this is the agenda I'm going to talk about. So I'm going to talk about like what's Akamai and how Akamai CDN map the traffic, and what are the best practice and recommendation to work with the Akamai. This is actually more for the network operators. So in case you don't know Akamai, this is a quick introduction of Akamai. So Akamai is a connected cloud platform, and we have a lot of edge servers and also a compute node globally. So talk about the CDN node that we have 340,000 servers spread across globally. And this is a high-level deployment of what we have in Taiwan here. So in Taiwan, our CDN nodes are in different major cities, in Taipei, Taichung, and Kaohsiung, and also in all the major Taiwan ISPs. Of those, we also have, other than server inside the ISP, we also have infrastructure nodes in data centers. And just one thing that I want to highlight is Taiwan actually have been doing a good job in terms of IPv6 adoption. It has increased dramatically since 2018. I think thanks for TWNIC and all for government for the policy. The adoption may have been towards about 40%. I hope that it will keep increase. So I'm going to talk about how Akamai works for the CDN. So some basic facts first. So number one is because when I talk to a lot of network ISP, they always ask, hey, is Akamai cluster connected? It's actually yes and no, or depends, because some of the clusters are connected, but most of them are not. So they are more like an islands. They don't They are individuals. They connect to the ISP and they connect to the public internet. And the second question would be where does the Akamai content come from? So of course we are a caching platform. We are more a delivery platform. We don't own the content. So the content will be from our customer where they host their origin. And how do we map the traffic? So basically we map based on a lot of factors, but primarily we are based on the client DNS. So to you, it will be the ISP DNS that we use. So and then I mentioned that we have a lot of clusters globally. So here are different type of clusters. So we have one that we call private. That means dedicated only for a ISP. So for example, in Taiwan, we will deploy in, let's say, Zhonghua, Daguodai, Yuanquan, all these big ISP. And then we do have infrastructure node. That means it's a shared resources that we connect to other ISP. It could be connected to a internet exchange, ICHA, or it could be connected to different network providers, cloud providers, OTT providers. So we do have the infrastructure in Taipei here, one in Zhonghua Banqiao data center, and the other one in Chief Leiwu data center. So here's how it works when it comes to the Akamai CDN. So you think about that from the left-hand side, there's end user. So when the end user trying to request a content that hosted by Akamai, so we try to map it to the closest cluster. So we read it inside an ISP, and then we have a cache server that will map the user to the ISP. But the ISP probably don't have the content itself, I mean the cache node, so you go to the origin. Or if you don't have a cache node with the ISP, you may go to one of our public cluster. So there are a lot of different clusters that we can send traffic to the end users, depend on the network situation, the ISP, DNS. So once the request sent to the edge node, you have to fetch the origin content. The origin content could come from the customer itself, they host their own infrastructure, or it could be going to another cache node if the customer have a multi-layer of cache configuration. So that's why we call it mid-tier, and that's why the content don't go directly to the origin, but it go to some other intermediate Akamai cache node first. But it is per customer configuration, so depend on our customer configuration. So now, if you are running a network, you will always think about how you could optimize your traffic flow from Akamai, because we do have a lot of traffic and content to be sent to the end users. So a few things to note is because number one is we map traffic based on network performance. So it mainly depends on latency, packet jobs, and link utilization. It also depends on our server capacity. So sometimes maybe the link is not full, but our server capacity is full. Or it could be that cache server don't have that content. So it depends on a lot of different policies. So just, I think earlier this morning, that Taiwan have an OTT policy. So that's why we also conform to the regulation that some of the OTT content may not be able to serve within Taiwan, for example. So there are different type of, and there are also customer configuration. So customer may choose how they want to serve their content. So there are a lot of different factors affecting how we map traffic. But just from a network perspective, because we are sending traffic in the most optimal way. So sometimes you will find that like the traditional traffic engineering method may not work because like AS path may not work. Because for us, once we receive a prefix and we find that the performance of that path is good, we actually ignore that AS path length. So we send the traffic way away from there because it's a better performance. So we don't take into the BGP. The other thing is because, as I mentioned before, all our clusters are independent islands. So if you trigger AS path, it's only impacting that cluster. It don't impact other clusters. So other clusters, because they're not connected, so they don't know the prepend, they will still send traffic anyway. So because a lot of ISP is trying to prepend on the transit, but they want a shorter AS path on the PN, on the peering. But in our case, sometimes it may not work because you just choose the most optimal path. And next is MED. MED actually works, but if your connection are on the same cluster, then we honor the MED. But otherwise, because you send MED to Akamai, maybe end up actually sending to different cluster, then we don't see that MED difference. So again, so MED may not work very well with us. And then next is prefix links. That means a lot of ISP also try to send specific routes. So they want to steer the traffic to a particular link. But then in Akamai, we may see that, okay, if you have a covering, that means you have a shorter prefix length prefix, then we may send it from there. Because we think that if you have a set23, then we will send traffic from that set23 instead of a set24. Because if that's set23, that means we can send traffic to that whole set23. So it's not, and again, because we are all cluster are independent, so we probably one cluster set a set23, but we don't see the set24 there as well. So there's a lot of these common BGP techniques actually do not work very well with our CDN platform. Because, as I mentioned, we use a CDN method which is proprietary, and based on DNS, so we map based on the BGP, but on top of DNS. And then we also don't have backbone, so chance is if you connect to one of our cluster, you don't get all the content as well. And we have a lot of other factors that are impacting how we send traffic, like what I mentioned before, like where's the content placement, also our server capacity, link utilization, and also a bunch of network factors. So because we want to send from a most optimal look that have the most optimal performance, so we cater in all these network parameters. So what we suggest is, because you can't control a lot with them, so if you have an issue with Akamai traffic that on a particular link you have too much or too less traffic, then you can always talk to us. And today we have, other than me, we have our network support, Cindy here. So you can also talk to her as well. So, and then in the next section, I'm going to talk about our best practice and recommendations. So we can work together on how we can see the traffic. Because at the end of the day, I think ISP and Akamai or all other CDN provider, we are actually on the same boat. We have the same goal that we want to optimize your user experience. So we don't want to like congest your links. We don't want to make you have a very high network cost. We want to cooperate better so that we know where we should send the traffic in a more predictable way. So here is what we recommend if you want to have a more optimal traffic flow from Akamai. So number one is use your own DNS servers, because as I mentioned, the fourth mode that we map traffic is based on DNS. So it's better you have your own DNS infrastructure. If you have to use a third-party one, like you have to outsource one, or you don't want to manage your own, I would suggest that you use at least Google and OpenDNS, because we do have ECS with them. That means end-client subnet. So we can look into the end-user IP to map the traffic. It's not optimal, but it's better than using other first-party. But I think in Taiwan case, I think a lot of ISP actually have their own infrastructure. And if you have your own DNS and if you're national-wide, I would suggest that you also set up your DNS in terms of like a anycast setting, so that the traffic could go to the most optimal node. And maintain a good connectivity to your DNS server, because we use that DNS server to measure the performance, because I mentioned before that we measure a lot of latency, packet loss, so chances we may use your DNS IP to do the measurement. Next is also quite common, because as I mentioned, a lot of ISP want to do traffic engineering and want to shift traffic from one link to another link, but it doesn't actually work very well with Akamai, because when we map traffic to one particular node, we expect that we can send traffic to that network from that cluster. So that means you have to send us the complete WAW announcement. So if you peer with us on any IX or on any PNI, you better to send us all your prefix so that we can send traffic consistently. If not, then we may have a chance that we have to block that, because we don't want to avoid third-party traffic that is suboptimal. So maintain a complete and consistent prefix when you have a peering with us. Next is do not filter traffic. What I mean is, number one is if you announce a session fee to us, we will expect that we can carry traffic to that whole session fee. Because we may not get a specific route somewhere because those are independent islands. So if you're not doing that, then if you backhaul the traffic, then of course it's impacting your end users. Number two is if you could allow at least ICMP filtering, ICMP ping, then we could do measurement so that we can know exactly the performance to your network, so that we can find where is the most optimal node to send the traffic. Next is also if you are a provider, so try to avoid carrier-grade NAT and shift to IPv6. Because number one is carrier-grade NAT device actually not only costly, but I think it's very inefficient in terms of delivering traffic. So you have to do the translation. So I suggest that try to avoid using any NAT device and try to shift to V6 if possible, so that you can bypass the NAT device. And of course, Akamai is fully supporting V6 as well. So if you have any cache node or peering with Akamai, I would suggest that at least you have an IPv6 session with us as well. Of course, on your end user front, you also need to make sure that your end user are reachable for IPv6. And Taiwan doing quite well, actually. Because V6, we do research that actually is actually having a better performance because it could bypass a lot of NAT, etc. So as long as we can do native V6, yeah, that's better performance as well. So this is my summary. So I just want to highlight again. So the Akamai CDN is a highly distributed platform. So a lot of edge server for the CDN, and our DNS use. So our CDN use DNS to map the traffic. So a lot of traditional BGP traffic engineering company may not work with us, but we are willing to collaborate with the network operators here, so that we know how we could optimally send the traffic. And I mentioned some of the best practice and recommendations, so I just summarize here. So try to have your own DNS infrastructure, maintain a consistent and complete prefix announcement. Do not filter traffic or backhaul traffic. Try to avoid carrier-grade NAT, and also try to enable V6. So these are all best practice that you can try to optimize the traffic flow from Akamai. Of course, last but not least, I would encourage that if you have a network operator, and talk to us if you have any issues. So that's all my presentation. If you have questions, this is the email that you can send to me. And if you want to peer with us, we have all our peering information on the peering DB. So thank you. 谢谢.
Okay, thank you, James. And it's help for the operational technology, and traffic flow. The management is very important for ISP. So the James, the recommendation is good for us and for you all. Okay. Okay. And any question for this topic? Okay. Okay. No question. This session is closed. Thank you very much for your all. Okay. Thank you.
Yes, thank you so much for this wonderful sharing.